Hello, so for this video I just wanted to say a few words about how to actually perform the build process with the Agile Deployment Toolkit. Basically there's several sets of scripts which run on different parts of the infrastructure. So you have like a web server script, an auto-scaling scripts, database related scripts, assets management scripts, and a mail server scripts. But you also have a set of scripts which I call the build client scripts, and these are the scripts that you need to run to actually initiate a deployment into your cloud host of choice. So the standard way to do this is to pick any cloud host provider you like, really. It doesn't matter, and deploy at this point in time either a Ubuntu 16.04 and up instance or a Debian 8 instance. And the reason for that is that the scripts are tested to run on those versions of those operating systems. So any other flavour of Linux they're not tested for and therefore not supported, although they may be in time. The idea then is to have a build server running in the cloud that you can run your build client scripts on. So you can see here I have a 512 megabyte Debian instance. It's actually running on the DigitalOcean cloud, and it's just a vanilla Debian instance. You obviously need to secure it with your SSH keys and so on, and perform security on it as you would if it was a web server or any other important machine. And the reason for that is that your credentials and access keys will be stored on this machine. So that's the first thing you need to do then, is just spin up either an instance of Ubuntu or Debian on a cloud host of your choosing, which may or may not be the same cloud host as you're actually deploying your servers to. So once you've done that, you need to, I've just created a tutorial directory here for this tutorial, then you need to clone the build client scripts from GitHub. So let's just grab the HTTPS clone URL from GitHub. So you can see the name of the repository is the Agile Infrastructure Build Client Scripts, and we just do git clone, install git on your machine, apt-get install git if it's not already on there, and then we pass in the URL like that, and it asks whoops, try again. That's better. So that's now cloned the repository into my tutorial directory. So the next step is to cd into the directory that's created, and there you can actually see the build client scripts. Okay, so that's all you need to do so far. The next thing then is, if we just look into the build scripts a little bit, if we look into this directory, build scripts, this is the heart of the deployment process. So these scripts will actually build us an autoscaler, a database, set the environment, build an image server, the mail server, and the web server, and all of that is based on the configuration parameters that we set when we run the root level build script. So these other scripts here are all just initialization scripts and so on. So these are the main actual scripts which are actions to do the build processing. So that's the build scripts directory. In the helper scripts directory, these are basically just some helper scripts that enable you to manipulate your servers. So these ones are all scripts for connecting to particular server types. If you want to connect to your autoscaler, you just run this script, bin sh, and then the name of the script, this one, and answer the questions that it asks, and it will connect you automatically to your autoscaler. Similarly for the DB, image server, mail server, and web servers. These scripts will copy a file to a particular server type. So if you need to upload a file to your server, you can just have it on your build client and upload it to the particular server type. Can't remember what that one's for, or that, to be honest. This monitor script enables you can run this script to monitor the uptime of your web server. This will actually reboot all your infrastructure, so each server is rebooted. This resets the build kit, so when you run a build, there's various configuration settings which are stored in this build scripts root directory, and so reset just gets rid of all previous configurations and lets you start with as it was when you first cloned it. This will shut down the infrastructure. This will do a backup to your data store, which is Amazon S3 or Google Cloud or some other provider, and that's a script which is run from within that script. So that's the helper scripts basically. And then the provider scripts, these are the scripts which abstract all the different provider services. So if you look into the cloud host one, for example, if we put let's do server, I think that's, so if we do create server, we can see that this script abstracts for each of our server cloud host providers. We support 4 at the moment: DigitalOcean, Exascale, Linode and Vultr. It abstracts all the gubbins to do with actually creating the server for that provider, and so you can see that it's very simple to add an additional provider to the so for each of the scripts in the server directory, if you want to add a new provider, you just do the cloud host check, I don't know, some other, can't think of one, some other provider that you want to support, and then you just put the relevant code for creating a server on for that provider in that part of the script, and then basically you build up your support for another provider in that way. And so it's a common interface, and so if you see from the if we look at the autoscaler build script, we can see where we call create server, there's only one call. It's nothing to do with different provider types and so on, so it's the same call whichever provider we're using basically. So that's an abstraction of the provider specific coding into a generalized form. Can't say that it will work for every single provider out there, because there may be some idiosyncrasies, but certainly for the 4 that I've tried, it works, and so it should be possible with other providers as long as they have a publicly accessible API to work with, to provide an abstracted common interface. And so in that way you could support 10, 20, 30 different types of cloud hosting services, and the users of the toolkit then get a free choice to deploy to any one of the cloud hosts that they desire. So like I say, at the moment there's only 4 supported, but hopefully that will grow with time. So that's the provider scripts, and so there's different so for example with the Git stuff we abstract a few. If we look at Git pull, we abstract to different providers that we support, so Bitbucket, GitHub or GitLab. So you can have your code in any one of them, and you just set it as a configuration, which you'll see in a minute when we run the script, and it will use the repository provider that you've configured it to use. Data stores. So you can see there we have 2 different data stores at the moment, Amazon S3 and Google Cloud. We could support any number more of data store providers. It's just a matter of adding them in and so on. I did do some, so you'll see in the documentation I did do some stuff to do with so we have in the documentation subdirectory we have documentation to do with development and documentation to do with deployment. If you look in the dev one, you should see some rudimentary documentation on how to add, so adding a cloud provider, for example. So it tells you what scripts to modify to add a new cloud provider. Now these scripts were accurate probably 3 months ago, but I've made a few changes since then, so they might not be entirely all-encompassing, so I either have to find the time to go through it again. So I think when I was adding the last provider I just figured out, right, what scripts am I modifying here to add this provider, and documented it. But there's been a few changes since then, so with these scripts I'm not sure they're 100% up to date still, but better than nothing, and if I get the time I will rewrite them. So then the other one is just this descriptors directory, and so for each of the server types we just pass in a load of descriptors or stuff that we want configured basically. So there's one for each of the scripts, which you can then see is red. If we look in here we can see that it is red from here. It actually reads the descriptor file and performs a copy basically. So that's that. So you can see the descriptor file is here, or is it? I don't know, can't remember now. But that's the process basically. Oh, here it is, sorry. So it's passed into this while loop basically. So that's that, and then the next thing is just the top level, and at the top level we call each of these scripts basically in turn. Similarly, pre-processing and post-processing, and these ones as well. Emergency autoscaler deployment. if we want to be entire, so we have a single autoscaler and it's responsible for some of the core functionality of the architecture. So you know, we're not involved in safety critical systems here. This is for people's social networking sites. So you can imagine once every 4 years or something there'll be a issue with the autoscaler or some other problem because it's just a single machine. So in that case, what we can do is we can take the autoscaler that's running offline, run this script, and it will deploy a new autoscaler. So that would limit, once you know that the autoscaler's gone offline, you can run the emergency autoscaler, and within 20 minutes or even 5 minutes you have a new autoscaler online and your system is back online. So the truth is that should never happen, but the advised principle of architecting systems is to never have a single point of failure. So that's the way that's been kind of accommodated. Okay, so the next thing then is, if we look at the script at the top here, this is the main root script which coordinates all of the top level deployment. So that's the script we're going to run basically. I'll try to use a fairly clear coding style. I don't think there's anything too incomprehensible there. And then, so if we want to do a deployment, we just run it. So bin run it through the shell. So the first thing it tells us is okay, you need to be responsible when you input the data to the script, because it does a lot of sanity checking, or at least as much as it can, on the inputs that you give. But still, if erroneous data is input, it's possible that there could be unintended or unexpected behavior during the deployment process. So basically it's just saying double check everything that you enter to this script. So it doesn't seem like we've run this script before on this machine, so press enter when we are ready. So the first thing then is to set the time zone. So we're in Europe, and then we have to tell it a city, so London. Let's give it a build identifier, so we'll call it Bucks, and you can see there then are 4 choices of deployment option. So if we pick 3 for Linode, we give it a password. Linode requires a password for its first create operation, and then we switch off root password access basically, and everything has to be done by SSH keys. So we can deploy either Ubuntu or Debian. So let's pick Debian version 8. So the way this is designed is that basically you can plug in different application types. So if you become an application developer, so say you pick your CMS of choice and develop an application for it, or specialize it into a, I don't know, an e-commerce application or something like that, then your application might need some specific customization based on its application type. So when you install an application, you give it a type basically, and then if you look through the scripts on the database and the web server, you can see that there will be customizations made specific to each application type. So if we're installing a Virgin CMS type, we don't need to do any specific application customizations, okay? So that we would pick type 0, but in this case I'm going to deploy a social network application type which I have built, and you'll see in the other videos. So we choose basic social network, and the customizations for that application type will be applied as the application is deployed. So if you developed an e-commerce application type, for example, you might have type 2, a basic e-commerce application. Okay. And so that's the way that that's done. So it's written in PHP, so you have to tell it to install PHP basically. At later dates, other systems could be added to that if there's applications of those types also. So we'll call it a name. And so then we have to apply the caching system. So if we put none, then file system caching is used. 1 is Redis, 2 is Mcached, and 3 is APCU. APCU didn't seem to work too well with Joomla in my case. I couldn't seem to make it performant, but that's probably me more than any problem with the setup. So if anybody knows how to make APCU performant with Joomla, then that would be cool. But basically I have a choice, because it's a Joomla application, in between Redis and Memcached. So let's pick Memcached, and then I have to decide what web server I wish to deploy to. So we support Nginx, Apache, and I don't know how you say that, the light to something, I don't know, the light one anyway. So let's pick Nginx. So with these web servers we provide a basic, or the common configurations basically. Now they're nowhere an expert at configuring web servers and stuff, so I've just done the best I could, but if anyone knows how to configure web servers better, then by all means that would be something cool. So we picked Nginx, and then we need to figure out which DNS service you wish to use. So usually you will have purchased a domain name from a DNS registrar, and it doesn't have to be Cloudflare or Rackspace that you get your DNS name from. In fact, I'm not even sure if you can, but what you have to do is you have to set your name servers with your definitive DNS provider to point to, in this case, either Cloudflare or Rackspace. So it's worth remembering. So my DNS is hosted with FastHosts, and I have changed the name servers to be the Rackspace name servers for that domain name. So basically that's the one that I have to use. If I want to use Cloudflare, I have to go to my FastHosts account and change the name servers to point to Cloudflare basically. So in this case I'm going to use Rackspace. Then it asks me for my Rackspace credentials, so I'm just going to pause the video here while I get hold of my Rackspace API key, and so by pausing it I'll keep it private. Okay. Okay, so I've entered my Rackspace API key and set the region to London. Now the next thing is to use the Git credentials. So if you know about git.config, and it asks for user.name and user.email, I think that's these credentials. So you put them in. Like that. Then we have to decide where our application source code is. So you can store your application any one of these providers basically. So if you have a preference, you can use that. My application I'm deploying is currently stored in GitHub, although last week it was Bitbucket, and so it's quite possible to move them around. So I need to select GitHub and the owner of the application, so that's the person's name, GitHub username, who owns the application, so that's me. And then this is your own GitHub username. Okay, so whatever your GitHub credentials are, in this case it's the same. And then you need to put your password in and confirm it. So then this is where the Agile Deployment Toolkit is stored. So again, at the moment this is stored in GitHub, but that's the code base that I am responsible for. So previously was your application that you develop, or somebody else's application that you're deploying, and this is the code base that actually defines the infrastructure of the Agile Deployment Toolkit, so that's under my control. So it's in GitHub and it's under that username, so you will have to enter that also, and then your GitHub username, which in this case is the same. So you need to have read access to these scripts as it prompts you here. Okay. And password, and then it just does some checks to see that it can access all the repositories, and if it continues like that then it can do. So then we need to decide if we want to install a database. Now for some applications, if they're just a static application, for example, you might not need a database, but in this case we do, so we want a database. I do want a single instance or a high availability database cluster. In this case we just have a single instance, and you have a choice here. So let's pick Percona, and it then goes off and queries our cloud host provider. So we've set the region for our DNS system, which was with Rackspace in this case. Now we need to set our region for the actual cloud host that's going to be running our server systems. So let's pick London. So these are actually queried and returned from the Linode cloud host provider. Okay, so we put in London. Then obviously the larger the machine, this is the size of the database server, the higher the cost. So just be aware of that. If you're putting in a machine up here, then you're going to get quite a bill. So let's just put in the smallest machine and the web server, and the image server, let's say we don't want an image server this time. Basically, if you don't have an image server, your assets are stored on the file system of your web server. So with an image server in place, you can potentially grow it to be many image servers which are unified through a system called MHDDFS on the web server. So there's probably, I haven't tested it fully to be honest in terms of scaling. That's where I need real world usage. so there's probably a slight performance hit on actually using a system like that, but it enables us to have a set of image servers basically, so we can have maybe as much as a terabyte of disk space on each image server. So that gives quite a high level of disk availability if you're running a social network or something where people are uploading graphics and so on. So that's it basically. The reason why I have image servers is that not all applications support or can support CDN systems. So in the first choice, ideally your application would be able to support a CDN, and you would use that as your image and assets mechanism. But if your application can't support a CDN, then the fallback system is these image servers which I've set up. So that's the basic reason for that. So hopefully most applications would use a CDN, but they can use image servers if they wish to. So we won't deploy an image server this time, and we're not using a CDN either, by the way. So the autoscaler, let's say that's 1024 as well. The mail server has to be at least 2 gigabytes, even though we're not going to deploy a mail server this time round. It still asks the question. And the idea is that if you want to run your own mail server, you can, but basically it's quite a responsible role to be admin of a mail server. It depends on your resources whether you have the time and skill to run a mail server. So I'm not particularly brilliant at it, so I usually decide not to run a mail server. The advantage is if you run your own mail server, you can have all your users with an email address which is specific to your domain name. But as I said, it's a responsible thing, because if people rely on their email using your domain name and you have a problem with your mail server, then that can cause them some problems. So maybe you need to have a caveat which says if you're not fully sure about how to run a mail server, disclaiming responsibility if anything if it goes belly up basically. So it depends on you whether you want to run your own mail server. But as I said, the nice thing is that you can give your users an email with your domain name. So if you're running a social network, that's quite nice, because you can have the domain name of your social network and them have an email address with it. So then we need a data store. So this is where, when we're using our image servers and so on, the assets are persisted in between boots of the servers or redeployments. So if assets are added to the image server every 5 minutes or so, or every so often, it syncs with the data store, which in this case is either Amazon S3 or Google Cloud. So let's pick Amazon S3 this time. Super safe backups. So basically we create backups hourly, daily, weekly, monthly and bi-monthly. So normally those backups are persisted to your repository provider of choice. However, that's only a single place to back them up to, so we also provide super safe where it's kept in your data store provider as well. So the data store, which is storing your assets and so on for your image server, also acts as a backup for your code base. Okay, so if you want super safe, then you can switch this on. I recommend that you do, because you never know, if just a backup in a single place, things can happen. And that's the basic way of doing that. And also if you wanted to, you could do a weekly image of your code base to a USB stick or something, and then you've got 3 backups of a manual backup, I mean, and then that way you've got 3 backups of your code base all the time. So if anything happened to that, then there's probably some huge disaster going on. So we can do that, and then we have to decide, do you want to deploy in development mode or production mode? So basically the normal development cycle would be you would deploy a virgin CMS instance of Joomla or WordPress or Drupal or something, and then you would develop in development mode. So that would just be a single web server with a database and probably no image server or anything like that. And then once your development cycle is complete and you think, right, this is a baseline of the application that I'm building, the other people can then deploy and specialize themselves. That would be you would take it out of development mode and put it into production mode. The difference between development and production mode is basically development mode has just a single web server and a lot of the features are switched off, such as auto scaling and so on. In production mode you have auto scaling and various other aspects which are enabled. Okay, so in this case we'll pick development mode, and then we have to decide what we're deploying. So if it's a virgin CMS, we pick number 0 and then select the CMS you want to deploy. If we want to deploy from our backups, then we pick hourly, daily, weekly or monthly or bi-monthly. In this case we're going to just deploy from our baseline. So this is the version of an application that we have developed in development mode, and it's ready now to be put into production. So we just click on baseline build, and then in this case I can just copy the repository name from here. So that repository name, if you look in my where are we here, in my GitHub, that's this one. Okay, so that's the actual Joomla application that I have developed. Okay, so that's what I'm selecting here. It did some checks there to check that it was available, and then the database is a backup of the database for the application, and it seems to like all of that, so it just does some configuration checks that it needs to, and once that is done, we can decide if we want to run a mail server, which we don't in this case. I'm not into that really. And then so if we just I can just put a dummy email address in here. So this would be the email address where your system messages are sent. So if you're the system administrator, well, let's do it. Oh well, no, let's just put a dummy one in. So if you're the system administrator, then you can set an email address where you receive system status messages, basically. So this is the SMTP system. And then for SMTP providers, we currently have SMTP Pulse, which I think probably costs money, and Google, which is the Gmail, standard Gmail system. So let's pick Gmail. So this is then the Google Gmail address where it's going to be sent from. And so these system messages will be lost because I've just put a dummy email address in, because I don't want my email address, I haven't set one up yet for system messages. So this is again the Gmail one, and then the password and then the build actually starts. Wow. So the first thing it does, it just gives you a little message to say that if your cloud host, like for example Cloudflare, has DOS or DDoS detection, then you need to whitelist your autoscaler's IP address, which is just about to be assigned. The reason why is that the autoscaler does some monitoring of system status and so on and uptime, and if it keeps on accessing your website to see whether it's up or not, then if the DNS service provider has denial of service attacks detection, it says what the hell's this, so you need to whitelist your autoscaler's IP address. Okay, otherwise the monitoring methodology will be inconsistent and it will show failed monitoring requests when in reality the website was up and it was given a challenge response or something. So we just leave that now. I'll pause the video and show you in a minute what the website looks like at the end of the build process. Hello, so the build process has completed, and you can see what the output looks like. So if you remember, that's where we were before, and it completes here. So that's the idea of it, and you can see various bits of information here, passwords and so on. So that's why you need to keep your build client secure, or your build server machine secure. So you can see the credentials are stored there in the file system. Yeah, so that's what the build looks like basically, and then the website, there you are, that's it. That's the actual live build of the website. So there you go. Okay, so that's it for now. Bye.